Here we have an Oraimo inverter that was sent over for repair. This is actually our first time working on this Oraimo inverter. We've only seen it on marketplaces, but we've not actually worked on it before. This one was damaged on site. I've asked the installer and he said he doesn't know what's happened because they were out doing solar panel installation. The customer wanted to add more panels. So while they were doing that, after finishing the installation, they came down, test the inverter and powered it. The inverter did not power. And it was like what was going on because it's just panel installation that they came for. So he rushed over, gave us a call, and we told him to bring it over. And he brought, and here it is with us. We went through it, did some physical inspection, and we found out that some MOSFETs were bad. And the heat mark on the MOSFET shows that this one isn't something that they cost. Maybe this had fault before, and they were kind of caught up in it. So we actually did our test, and the MOSFETs were bad. So we checked on the IGBTs too, and we also found out that the IGBTs were also bad. So this shows that this was something else totally. Now, the section of the IGBT that was bad was the section responsible for the charging stuff, mostly the input section of the inverter that was actually bad. So we tested it, they were bad, and the MOSFETs were bad. This was an all-out damage because all the MOSFETs were bad, and five of those IGBT were bad. So we begin repair. Now we've removed the screws and we are taking out the MOSFET and the IGBT screws so we can begin full repair on this particular system. We now desoldered the IGBTs. This was using 70 and 65 IGBTs. So five of it were damaged. So we are going to remove them and get new ones to replace. During most of our repairs, we normally don't start from the IGBT section, but this time around, we say we should go all out and start from the IGBT section before the MOSFET section. So we tested the IGBT. I'll find out that three of the IGBTs were actually bad, two were okay, but we are going to replace all of them. After removing the IGBTs and clearing the path for new ones, we went ahead to test the diodes. We have 18 volts diodes that are there, and the normal 1N4148 diodes that are also there. So we have to test all of them and also test the gate resistors to make sure that they are okay. If any of these components are bad and we end up replacing new IGBTs, it will just go bad again. So we need to make sure that all these components are good. That's why most times we normally retest. After we've tested, we retest. Even when we put in new components, we still test it to make sure that all is well. So once you finish repair and test, straightforward, no loopholes or no stress again. So that's just it. So we went through all of them one by one, and everything concerning the IGBT section, we are okay. We checked the optocoupler section that was driving one of the IGBT in reference with the other four. Those ones were okay, and the power supply, that is the one that powers the optocoupler, is also okay. We checked the diodes and everything is working fine. So we also checked the section that was driving one of the IGBT, that optocoupler there. We checked the diodes that are powering it there to make sure that they are okay, because if those components fail, it will probably throw you an error code. That is the funnest part of it all. It might be error 09 or most cases error 52. So we had to make sure that all those components they are okay. and now we got new IGBTs, five of it to replace in that part. Now we've installed the new IGBTs, five of them in their correct positions. So now we'll solder them and move on to the MOSFET section, because that's where the real work is. Like I said earlier, when doing repairs, we always double check. We went all over it again, the diode, the MOSFETs, we checked it and make sure that everything is okay. And actually, that point there, before now, when we tested it, that diode was shorting. So the IGBT was actually the cause of that short there. So once we removed the IGBT, everything was okay. So that's just it. And the most important part of this all is the cleaning. Always make sure that we clean after every work, because of tiny particles of lead. Those things can cause you a whole lot of trouble or actually make you repeat the repair again. So that's just it. Now we desolder the MOSFETs that are bad. Actually, all of them were bad. This one is not even a case of few of them. Everything was bad, as you can see, many. So we are going to be replacing that. But first of all, let us clear the path for new ones. Now we test the gate resistors. They are actually 22 ohms. Each of them 22 ohms connected to the gate of the MOSFET. So we go through all of them. If any of them is bad and we put in new MOSFET, it will damage it. So we have to check all of them, and also we will check the gate drive components. Now we check the gate drive components. We have 10 ohms there, we have 200 ohms. We go through each and every one of them. Also for the transistors there, we have the 2SA1020G and the DKG transistor, NPN, PNP. We also have some Zener diodes there, 15 volt Zener diode, 18 volt Zener diode. So we have to go through all of them to make sure they are okay. If any of them is bad, the system, if it doesn't damage the MOSFET, it will probably throw you an error code. Most cases it was 09, most cases it will just blow up the MOSFET. So we actually have to go through each and every one of them. Doing this kind of checks on this particular system normally takes time, and we have to make sure that all is okay. Because if any of this goes bad, it's going to become a serious problem later on. So we have to take our time, check it. Now we are summarizing our checks on the gate drive component. This comes as a surprise, but none of them are bad. Most cases, a few components will go bad, maybe transistor, diode, or mainly gate resistors will go bad. But on this one, none of them are bad. So we just move on to installing our MOSFETs, our new MOSFETs, so we can be able to test the system. So these MOSFETs are NC MOSFETs, same as the one that we removed from this system. We almost done soldering the MOSFETs, and now we will clean the board because of those tiny LED. We don't want any of them joining any place and making the work hard. So now we are done with soldering of the IDBTs and the MOSFET. We replace them with new ones, and now we check it once again, and there's no short now on the MOSFET line. So that MOSFET section is now okay. Now we proceed to assembly of the system so we can now test it. We actually noticed that the earth wire was not connected. I don't know who did that, whether it was the installer or I don't know who did that, but we joined that back and installed the fan and carefully put the board in place. Now we install the control card in place and we are assembling it for proper testing. Now remember to like and follow us on all social media platforms. We're on TikTok, we're on Facebook, and we're on YouTube. And our whiteboard repair videos will be coming up soon. So I want you guys to subscribe so that you get first updates whenever we drop it. We are now done with assembly, so now we have to test. The inverter is a 48 volts inverter, 5 kV to be precise. So connect the positive and negative. As you can see, we are done with assembly. Now we power it up for final tests. And there you have it. The system is now working and supplying. Remember to like and subscribe to our YouTube channel to stay updated on our latest posts.